A new scientific report has confirmed what Italy's monitors feared. The ground beneath Campi Flegrei isn't just shaking, it's tearing in a circle. Published in Science, the work uses a new artificial intelligence system to reanalyze 3 years of continuous seismic data from the volcanic field west of Naples. A collaboration between Stanford University and the Istituto Nazionale di Geofisica e Vulcanologia, the model detected thousands of faint signals that standard monitoring had missed. More than 54,000 earthquakes were identified, nearly 4 times the official count. The results outline a buried ring fault circling the core of the caldera. This fracture cuts roughly 3 kilometers beneath the surface, forming a closed structure that mirrors the geometry of past eruptions. It lies directly below the city of Pozzuoli, where streets have been cracking and rising for years. The earthquakes form a clear, circular break in the crust that acts as a pressure trap, channeling stress along its edges as heat and gas accumulate below. Most of the shaking occurs only 1 to 3 kilometers deep, shallow enough for even modest tremors to rattle homes across the bay. Swarms have grown stronger around Pozzuoli, Bagnoli, and Solfatara. Several damaging quakes have already struck, including an offshore event that fractured walls along the coast. Continued pressure within the ring could trigger larger ruptures capable of damaging infrastructure across Naples' western districts. No magma is moving upward. The activity remains confined to a narrow depth range with no deformation suggesting intrusion. The driving force appears to be hydrothermal pressure, heat converting water to gas and forcing it through fractured rock that can no longer flex freely. Temperatures inside the caldera reach about 350 degrees Celsius at drilling depth. Under those conditions, water flashes into steam and builds pressure in sealed pockets. The system inflates slowly from within, stress concentrating along the circular fault where brief slips release bursts of seismic energy felt at the surface. Activity has intensified since mid-2023. Seismic rates have quadrupled, and larger events are occurring more often. The same segments of the ring reactivate repeatedly, showing that strain is building faster than it can dissipate. Ground deformation measurements confirm that the caldera floor has risen by more than a meter since 2005, with uplift accelerating again in the past 2 years. AI processing has revealed details invisible in manual catalogs. Low-frequency hybrid quakes now cluster beneath the Solfatara and Pisciarelli fumaroles, vents that emit thick steam and sulfur across the northern caldera. These signals are linked to fracturing rock and boiling fluids just below the surface, evidence of rising stress within the hydrothermal system rather than magma movement. The internal structure of Campi Flegrei is now mapped in unprecedented detail. The ring fault aligns with ancient eruption vents and the circular depression left by the last major eruption nearly 5 centuries ago. Its geometry matches a resurgent block, a section of crust lifted by internal pressure, locked by friction, and fractured again when stress exceeds its limit. For the first time, the full seismic architecture of the caldera is defined. The new catalog allows accurate modeling of which fault segments can produce damaging earthquakes and how frequently they might fail. Several active lines run directly beneath populated districts, industrial zones, and coastal transport routes. Stability now depends on how efficiently heat and gas escape without forcing new ruptures. Continuous deformation, shallow quakes, and persistent emissions show that pressure remains confined within the ring. Italy's monitoring network maintains round-the-clock surveillance as the system continues to evolve. A reminder that beneath one of Europe's largest cities lies a volcanic structure still active and under strain.